Hi, welcome to Instant Math Answers. Today we're going to discuss quadratic equations. How do you solve quadratic equations? First, we're going to look at some simple examples. Then, we're going to look at the general formula to solve quadratic equations. Then, the project sum rule to solve quadratic equations, and completing the square. And we will solve the equations using three methods. So a general form of a quadratic equation is x squared times a plus bx plus c is 0. So if we fill in a is 1, b is 5 and c is 3, we get x squared plus 5x plus 3 is 0. So we will later solve this equation, and then it's handy to have defined this a, b and c so that we know what I'm talking about. But first we're going to look at some simple examples. Example 1. X squared minus 9 is 0. So in this case we only have two terms, a quadratic term and a constant. We don't have a linear term, no x here. So then it's really simple. First we move this 9 to the other side. So we get x squared is 9. Then we take the square root of both sides. X is the square root of 9 is 3. Or x is minus the square root of 9 is minus 3. So we found two solutions, x is 3 and x is minus 3. Let's check this. 3 squared is 9, minus 9 is 0. X is minus 3. Minus 3 times minus 3 is 9. Minus 9 is 0. Let's look at the following example. In this case, we don't have a constant here, but we have a linear term with the x. So what do? We observe that both terms have an x in common. So we factor out the one x. So the x goes outside, and we have in the parentheses 3x and minus 7, because this x is outside and one of these x's is outside, so it's 3x minus 7. So in order for this product to be 0, either the first is x is 0 or this second term is 0. 3x minus 7 is 0. So we move this 7 to the other side. 3x is 7. We divide by 3. X is 7/3 is 2 1/3. So we have two solutions, x is 0 and x is 2 1/3. Now we look at the simplest example of a quadratic equation you can think of. X squared is 0. So x squared is 0, we take the square root of both sides. We get x is the square root of 0, which is 0, or x is minus the square root of 0, which is also 0. So both solutions are actually the same solution. Both solutions are 0. So we just have one solution, x is 0. Let's look what happens if the linear term is on the right hand side. Then first we divide by 3 because on both sides we have a factor 3. So here we get 9 divided by 3 is 3x squared, and 3x becomes x. Then we move this x to the other side. So here it's on the other side. We factor out one x as in the second example. So x is outside, here we get 3x, and here we just get minus 1 is 0. So x is 0, or 3x minus 1 is 0. So we move the 1 to the other side. 3x is 1, x is 1/3. Two solutions, x is 0 or x is 1/3. Of course, the order of the quadratic terms and the constants and the linear terms can change. So let's look at this case where we start with a constant, then have the quadratic term is equal to 0. So x squared is just 3 because 3 minus 3 is 0. So we have x squared is 3. So we take the square root, x is square root of 3, or x is this minus the square root of 3. So we have two solutions, x is square root of 3 and x is minus the square root of 3. This is quite simple. So here we don't have a constant, just a linear term minus a quadratic term. So they both have a factor x in common. So we move this x outside the parentheses, and here we just have 1 because x times 1 is x, and here one of the x's is outside, so we just have 1x is 0. So this x is 0 or 1 minus x is 0. Okay, that's simple. X is just 1. Two solutions, x is 0 and x is 1. We can check this one, for example. 1 minus 1 squared is 1 is 0. That's correct. Okay, we still have only linear terms and quadratic terms, but we don't have is 0, so we first transform this such that we have 0 on the right hand side. So this 2x goes to the other side. We get x minus 2x is minus x, and this 3 goes to the other side, 3x squared, and then we have just plus 2x squared is 0. So we just interchange these two terms such that the quadratic term is in front. We factor out the x and we get 2x, and this x is outside, we just have 1. So x is 0 or 2x minus 1 is 0. 2x is 1. So x is a half because we divide by 2. So we have two solutions to this equation. Let's look at the following example because sometimes we don't have solutions. X squared plus 1 is 0. So we move the 1 to the other side as we did in the first example. X squared is minus 1. We take the square root of both sides. So x is the square root of minus 1, or x is minus the square root of minus 1. And since the square root of minus 1 is not a real number, these are no solutions. So this equation has no real solutions. So in both cases, we had either b is 0 or c is 0. So no linear term or no constant term. So then we don't have to use the general formula. But in case b and we have a linear term and a constant and a quadratic term, we can always use this formula, the ABC formula. So this just gives the answer to this equation. And the second solution is this solution. So we take the b, negative b, plus the square root of b squared minus 4 times a times c, and we divide everything by 2 times a. Or the same formula but with a minus sign here instead of the plus sign. Observe that this term in the square root is called the discriminant, and it tells us how many solutions this equation has. If it is positive, the solution there are two solutions. If it is negative, there are no real solutions, and if it's 0, there's just one solution, because this is 0 and this is 0, and it's the same solution. So let's just look at an example. X squared plus 5x plus 3 is 0. So we have a quadratic term, a linear term, and a constant. So we just look, a is 1 because there's a 1 in front of this x squared, the b is 5, and the c is 3. So we first calculate the discriminant. D is b squared minus 4 times a times c. So we just look, 5 squared minus 4 times 1 times 3 is 25, minus 12 is 13. So if we calculate the formula, this is the b, so that's the 5. This 5 goes here. This 13 goes here. And 2a is 2 times 1 is just 2. In the second solution, we just have a minus sign instead of the plus sign. So the first solution is minus 5 divided by 2, which is minus 2.5, plus the square root of 13 divided by 2, which is a half square root of 13. And the second one is the same, but minus half of the square root of 13. Let's look at another example. Half x squared minus 2x minus 6 is 0. A is a half, b is minus 2, c is minus 6. We first calculate the discriminant. B squared minus 4ac is minus 2 squared is 4, minus 4 times a times c is 4 minus 12 is plus 12. 4 plus 12 is 16. Solutions, the 16 goes here, square root 2 plus square root of 16 divided by 2 times a is a half. This half goes here. So we get 2 plus 4 is 8. 2 plus 4 is 6. Divided by 1 is 6. And 2 minus 4 is minus 2. Divided by 1 is minus 2. Now we solve the same equation a second time, but because we don't like fractions, we just multiply everything by 2. And then we get x squared minus 4x minus 12. 6 times 2 is 12. So we can use the same ABC formula with a is 1, b is minus 4, c is minus 12. B squared minus 4ac is 16 minus negative 48 is 64. So if we calculate the first solution, we get minus 4, but with a minus in front, so it's just 4, plus this square root of 64 divided by 2 is 8, plus 4 is 12, divided by 2 is 6, and the second solution is 4 minus 8 is minus 4 divided by 2 is minus 2. Sometimes we don't have to use the ABC formula. We can use a second approach, which is the product sum approach. And that is normally the case when a is 1. So let's look. A is 1, C is 3, and B is 4. So we have to find two numbers with product 3 and sum 4. So two numbers with the product 3 is 3 times 1 is 3, and the sum has to be 4, but yeah, 3 plus 1 is 4. So we found these two numbers, 3 and 1, that obey this product 3 and sum 4. So instead of this equation, we just have parenthesis x plus 3, another parenthesis x plus 1 is 0. So this 3 is this one, and this 1 is this one. So either x plus 3 is 0 or x plus 1 is 0. So we get x plus 3 is 0, x is minus 3, or x plus 1 is 0, x is minus 1. So we have two solutions, x is minus 3 or x is minus 1. So let's look at the minus 1. Negative 1 squared is 1, minus 4 is minus 3, plus 3 is 0. And negative 3 squared is 9, plus minus 12 is minus 3, plus 3 is 0. So this is correct. Another example of the product sum approach. So we have to find two numbers that are whose product is 12. So we have 6 times 2, that's 12. But we also have 4 times 3, it's also 12. But then we calculate the sum of these two and of these two. 6 plus 2 is 8, so that's not correct because it has to be 7. 4 times 3, 4 plus 3 is 7, so this is correct. So you just find all different combinations of numbers that are whose product is 12. So another one is 12 times 1, but then you get 13, and we just want to have 7. So we are really happy with 4 plus 3. So we put the 4 here and the 3 here, and then x plus 4 is 0, so x is minus 4, or x plus 3 is 0, so x is minus 3. So we have two solutions found with the product sum rule, and of course you can use the ABC formula, but in this case it's just easier to use the sum product rule. Another example, okay, I just changed the 7 into an 8, so now we use the 6 plus 2, the 6 and the 2, because 6 plus 2 is 8, and 6 times 2 is 12. So then we have x plus 6 is 0, or x plus 2 is 0. So we have x is minus 6, or x is minus 2. Two solutions found with the sum product rule. And now I change it into the 13. So 12 plus 1 is 13, and 12 times 1 is 12. So if the difference is just 1, you always have to use a 1, and then this guy is just the C. X plus 12 is 0, x is minus 12, x plus 1 is 0, x is minus 1. Another example of the product sum rule, but now we have a negative sign. So first look at the product. 3 times 2 is 6, but 3 plus 2 is 5, not minus 5. So we have to introduce two negative signs, because minus 3 times minus 2 is also 6, and minus 3 plus minus 2 is minus 5. So it was almost correct, but just we had to add two negative signs. So we get just two negative signs, and we are really happy because we found x is 3 is a solution, or x is 2 is a solution. Now both coefficients are negative. So we first just start with the 6 and think like, oh, 3 times 2 is 6 and 3 plus 2 is 5. So we have to do something with a negative sign. So just put it in front of the minus 3, but then it's minus 6, we're happy. If you put it in front of the minus 2, you could also get minus 6, you're also happy. But if you look at this sum is minus 1, which we want to have, and this sum is 1, which we don't want to have. So we choose this one. Choose the correct combination. So we choose the minus 3 and plus 2. So x minus 3 and x plus 2. And we have two solutions, x is 3 and x is minus 2. So let's check the 3. 9 minus 3 is 6. Minus 6 is 0. Minus 2 squared is 4. Plus 2 is 6. Minus 6 is 0. This is correct. Sometimes you can use special rules. Maybe you know this rule, x plus p squared is x squared plus p squared plus 2 times p times x. So for example, with p is 3, x plus 3 squared is x squared plus 6x plus 9. So if you have this equation is 0, you can just use this one, but you have to recognize that this is the square of 3 and this is 2 times 3. So this 6 is 2 times the square root of 9. 6 is 2 times 3. So if you recognize this, you can use this, and this is easier for solving quadratic equations. For example, x squared plus 6x plus 9 is 0. So we recognize that we can write it as x plus 3 squared is 0. So just x plus 3 is 0. But because that's the only solution, so x is minus 3. One solution. We can also use the ABC formula with a is 1, b is 6 and c is 9. We get b squared minus 4ac is 36 minus 4 times 1 times 9 is 36 is 0. So we see that we only get one solution because we get minus 6 plus 0 divided by 2 times 1 is minus 3. Minus 6 minus square root of 0 is also minus 3. 2 times the same solution because the discriminant is 0. One solution, x is minus 3. So both methods give the same answer, of course. There's one other special rule. Instead of the plus, we have a minus p, and then we get a minus here. So x minus 3 squared is x squared minus 6x plus 9. So we get a minus instead of a plus here. An example. So x squared minus 6x plus 9 is 0. So that is exactly this one, because minus 3 times minus 3 is 9, and 2 times minus 3 is minus 6. And then you're almost done. X minus 3 is 0, x is 3. This rule you can also use when b is not 2 times the square root of c, and this is actually called completing the square. This is quite hard to see how it works, so therefore we're just going to look at an example because it's much easier. X squared plus 6x plus 7 is 0. So what do? We just treat these first two terms and write them as x plus 3 squared, where you divide this 6 by 2. But then we have to subtract actually the square of 3, which is 9. Okay, we still have this 7 and it's 0. Then we move these two guys to the other side, so it's a 2 on the other side. So x plus 3 is square root of 2 because we take the square root of both sides, or x plus 3 is negative the square root of 2. So x is square root of 2 minus 3, or x is minus 3 minus the square root of 2. Two solutions. Of course, you can also use the ABC formula. You can always use it. Another special rule: x minus b times x plus b is x squared minus b squared. For example, with 5. So if you recognize this, you can immediately write it like this, and you have the two solutions. For example, x squared minus 9, you recognize that this is 3 squared, so then you can immediately write it like x plus 3 times x minus 3, and you have the two solutions, minus 3 and 3. We already discussed this equation in example 1, but this is a second approach you can use. We can also use the ABC formula with A is 1, B is 0, and C is minus 9. So B squared is 0 minus 4 times 9, 36. The B is 0, square root of 36 is 6, and 2 times 1 is 2, 6 divided by 2 is 3. Or negative square root of 36 is negative 6 divided by 2 is minus 3. So we actually discussed 3 different methods to solve this simple equation. Okay, let's look at this equation and solve it with completing the square. 5 times x squared minus 9x plus 7 is 0. First, we divide everything by 5, such that a is 1. So 9 divided by 5 and 7 divided by 5. Then, we take this x, place it here, minus 9 divided by 9/5 divided by 2, which is 9/10. So just make it 2 times smaller and place a square here, minus this guy squared plus this guy is 0. We move these two to the other side, so this becomes 9/10 squared minus 7/5, and then 9/10 squared is 81/100 minus also 100 times 20, so both numerator and denominator times 20 is 140 and 100. So this is just a fraction, it's minus 59/100 divided by 100. Then we take the square root of this guy and negative the square root, but because this is negative, we see this equation does not have any real solutions, and we can additionally check this by calculating the discriminant. 9 squared minus 9 squared is 81 minus 4 times 5 times 7 is negative 59. Negative discriminant means no solution. So with completing the square, we find that it has no solutions, and the discriminant also tells us that it has no solutions. Now we're going to solve this equation with 3 different methods: completing the square, sum product method, and ABC formula. So first, we want to have it in the general form of a quadratic equation. So we factor this out. We get x squared minus 6x plus 9, x times x times minus 3 times x, and minus 3 times minus 3. It's this. So we move this 4x to the other side. It becomes minus 10x. So then we place this x here, we divide by 2, and we take this one and minus square root of this 5 plus 9 is 0. We move these two guys to the other side, which is 16. We take the square roots. X minus 5 is 4, or x minus 5 is minus 4. So x is 9, or x is 1. 1 minus 5 is minus 4. So we have x is 9 and x is 1. Now the sum product method. First we do exactly the same as with completing the square. Still we get this guy. So the product has to be 9 and the sum has to be minus 10. So 9 is 3 times 3, but the product, the sum is 6. So we're not happy because we want minus 10. It's also minus 3 times minus 3. It's also 9, but the sum is minus 6. So we need 9 times 1. Oh, we're almost there because the sum is 10. We only need to add the minus signs in order to get it negative. So we put 2 negative signs, and the product is still 9, and the sum is minus 10. So we take minus 9 and minus 1. Minus 9 and minus 1. So x minus 9 is 0, or x minus 1 is 0. So x is 9 or x is 1. This is the same as what we found here. ABC formula. This is the same. We could look at this equation. A is 1, B is minus 10, C is 9. The discriminant is 10 squared minus 4 times 9 is 36, is 64. Square root of 64. 10 is negative 10 is 10. 10 plus 8 is 18, divided by 2 times 1 is 2. 18 divided by 2 is 9. And the second solution is 10 minus 8 is 2, divided by 2 is 1. 9 and 1, same solution. Let's look at a little bit crazy example. X squared plus 12 is x plus 2 squared. So we first multiply this out. So x times x times 2x, 2 times x, 2 times 2 is x squared plus 4x plus 4. So this x squared cancels against this x squared. So we have 12 is 4x plus 4. This is just a linear equation, not a quadratic equation. So we move the 12 to the other side. 4 also to the other side. It becomes 8. And we divide by 4. So we get x and we get 2. X is 2 is a solution. 2 squared is 4, plus 12 is 16. 2 plus 2 is 4. Squared is also 16. Let's do a short summary. A quadratic equation of this form. We first adapt the equation until it has this form. If this linear term is 0, you just move this c to the other side and divide by a and take the square root, a negative and positive square root. It's example 1. If the constant is 0, you get this and you factor out the x times x plus b, and then x is 0 or this is 0, which is a linear equation. That was example 2. If all parameters are non-zero, you can always use the ABC formula, but sometimes it's easy to use the product sum method. You find the product of two numbers that is equal to c, and the sum has to be b. We have treated that a few times. And if a is not 1, you divide everything by a, or you multiply by something such that this term is just 1x squared. Completing the square is an additional method, so you don't really have to know it, because you can always use the ABC formula or use the product sum rule. I worked at NASA, and I did well there, so I guess you guys don't have to know the completing the square. Okay, it's nice if you know it, but you actually don't really need it. But it's a method, so I discussed it. So if you like this video, I hope you visit this website and subscribe to this channel, and hope to see you next time for another discussion about some mathematical topic. Goodbye.